Hi James, how are you?
Hello.
Are you well?
Yeah, I am.
Are you back at school? Yes.
Yes.
There's a difference between the whiteboard behind you and the guitars.
Yeah.
Okay, I think we were busy with um we're still busy with the periodic table and the atom. But I think you've moved on slightly. So last week, did we look at F-power diagrams?
Yeah, we did.
And I think
Where it
if I
goes
can remember
up,
correctly,
down,
you
up.
did really well, yeah?
Yeah.
I just want to test you on one or two, okay? Some just um okay, but we'll get there. And then we haven't looked at a table of polyatomic ions. Now, in your textbook, there's going to be like a table with like the formula and charge for like ammonium, nitrate, nitride, oxide, uh, dichromide, stuff like that, and sulfide. That those are important ones that you have to learn.
Okay.
Have you seen that actually?
No, I have not.
Okay, you need to find a page now. There will be a table in your book with.
What would it be called?
It's just going to be a table of. They're either going to call it polyatomic ions or just uh, charges on polyatomic ions. It will. There will be like a table. You'll see it. But anyway, I'll explain to you why you have to learn that. We'll look at that today. And yeah, then I think we need to. I think we need to do Lewis diagrams as well.
Uh,
Have you done Lewis diagrams?
I have. I'm pretty sure, yeah.
Okay, so we'll look at Lewis diagrams as well. Trying to find chemical reactions. It's on the chemical bonding. Um, uh, ionization energy, we're not going to do yet. It's too difficult. Bonding, oh, chemical bonding. I don't have a specific one under with Lewis diagrams. Just want to check here. No, I don't have, but I'll set it up. So I first want to, before we start, just want to make sure there's something we haven't done yet or looked at yet. So let's quickly look at this example of magnesium here. It's magnesium 1224. So how many protons do we have?
12.
And neutrons in this case?
12.
And electrons?
12.
12. Okay, this is if it's a neutral ion. Okay, that's not a very good example. Everything is 12. But anyway, the purpose is just here to fill in the electrons on this F power diagram. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12.
Yeah.
Okay, so what we know of magnesium, magnesium will be in group 2, and that indicates that there's two valence electrons or two electrons in the outer shell or outer energy field or energy level. So each of these are called, this is energy level number 1. That's why it's N1. This is energy level number 2. That's why it's N2. And this is energy level number 3. That's why it's N3. This is called an energy level or a shell.
Okay.
Right. So, and the other thing that we know, magnesium is in period number 3. And that's why there's 3 energy levels. So now the next thing that's needed is you need to be able to also draw or give me it's either called I don't know what's called in English where you minimize the Aufbau diagram into electron configuration. Have you seen that?
Uh, I don't think so.
Okay, so electron configuration is just another way to write or to indicate the electrons around the magnesium atom. And it's just a condensed view or method to write an Aufbau diagram. So you're going to write 1s, and then you're going to make a 2 there because there's 2 electrons in the 1s orbital. And then you're going to write 2s, and there's 2
Oh,
electrons there.
Yeah, I've seen this.
You've
Yeah.
seen that. And then in 2p, we have 6 electrons. And then in 3s, there's 2 electrons. So this is Aufbau. This is called electron configuration. And then you also have a condensed configuration. This is also, some books calls this SP notation.
Yeah.
Okay, that's just another way of saying electron configuration. Now, condensed simply means the following. You're going to look at all the energy levels that's full, and that's going to be 10 of them. Then you're going to go to your periodic table and find number 10. Now, number 10 is neon. You see that?
Yeah.
That's always the noble gas just before magnesium. So there's magnesium. So the noble gas just before that one in the previous period.
Yeah.
So some students visualize it like this. This is the period magnesium is in, and just the noble gas in the previous one is always going to be that one. So then you're going to write neon, because neon represents all of this. This is neon. So you're going to write neon in square brackets. That represents the first 10 electrons. And then you're going to write 3s2. Okay, make a note of this. We're going to do one more, and then we're going to go over and continue doing Lewis diagrams. The Lewis diagram is grade 10. You just study them. You don't get a lot. So it's not difficult ones. They're kind of like set. And your textbook's got a list of them. Okay. Happy?
Yeah.
Right. Okay. So we do one more. I don't know. Difficult one. Look at this one. That is oxide, the ion of oxygen. Now, normally the oxygen atom, 816, will have 8 electrons. Do you agree? And 8 protons. But now, since it became an ion, it actually added 2 electrons. So it got 2 electrons. That's why its charge is now 2 negative. So the normal oxygen has got 8 electrons, but the ion will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the protons will still be 8, and the neutrons will be 8, but the electrons will be 10. Because when it became an ion, it grabbed 2 electrons. So now if you draw the Aufbau diagram, there's only 2 levels. So I'll only do these 2 levels. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's the 10 electrons.
Yeah.
So if I do SP notation or electron configuration, it will be 1s2, 2s2, and 2p6. That's your configuration.
Yeah.
Okay, good. And your condensed one will only consist of 10 electrons. Now, if you go to your periodic table, then if you have one in front of you, that will only be neon. It will complete all of these and nothing else. Okay, so quickly write that down. I'm going to be back in 2 minutes.
Okay.
Okay, I'm back, James.
Okay. I'm done.
Okay, there are a test on this stuff to do. Okay,
Yeah.
you have to complete the tests. So I'm still kind of worried because you're not actually asking questions. Okay.
Yeah.
So on the atom, there's like uh you can't do the ionization energy. So let me just quickly show you what I want you to do. I'm just gonna drop them here before we continue with new work. The ionization energy we haven't done yet, and you haven't done that yet. So I don't want to put that in there. Okay, so there's an electron configuration test one.
Okay.
This one you can do because this is about SP notation and off-power diagrams. Okay. Happy?
Yeah.
Okay. You can, if you want to, write that down. That's the code. If you type in that code in your search your tests, then you'll 83, then you'll find the test immediately.
Okay.
And then nuclear structure. This is 82. This you can also do this because this is how many protons, how many neutrons, how many electrons type of thing. And some of the questions here are kind of difficult. So this is the structure of your nucleus test, number 2.
Okay.
And then a nucleus structure number 1. This is 80. So 81, 2, and 3 you can do. 81, 2, and 3. And then we're not going to do ionization energy. We haven't done that yet. I'm not 100% sure if you are going to do it at this stage.
Okay.
Okay. Right. So now we're going to head over and start with chemical bonding. Where is the bonding? Oh, there it is. It's open already. Okay, so we're going to start with chemical bonding. That's the next chapter. Hi, Loving.
As
The class starts at 10, eh? Hi.
no, I did that admin stuff.
Pardon?
I did the work that you sent in on the group, man. So
Oh, did you? Okay.
yes,
I need to show you how to register and log in into a program where you can get the memos. You haven't done that yet. Loving.
no, yeah,
You haven't logged into a program yet, have you? Sorry, I can't hear you.
Yes, sir.
Okay.
Abby isn't here today.
Oh, who's talking?
It's loving, sir.
Okay, Loving. Just before we go on with the class, I need you to write this down. www.vsilab.co.za. Okay.
Oh, sir, I'm already logged in on that.
Oh, wonderful. And did you complete the test there?
I did like two
Oh,
of them.
awesome. Okay, great. Do you have any questions?
No, sir.
Sorry, I couldn't hear. No.
No.
Okay, wonderful. All right, good. So I just told James about the test that I wanted completed. I wanted everyone to complete. So what I'll do is I'll just drop those tests in the on WhatsApp for everyone, just to make sure that those are the 3 tests I want you to complete. Maybe you've done them already. I'm not 100% sure because I have dropped some of the tests in there already. Okay.
Yes.
Right. So now we're starting with new work today. And remember, you can always ask questions. Okay. We're going to start with chemical bonding. Now, Loving it, have you done, what is your name full? Is it Shamar?
Yeah, it's like Shama is my first name and Loving is my middle name.
Which one do you prefer?
Loving because it's easier.
No, Shamar is easier.
Not to a lot of people.
Okay, wonderful. We're going to start with Lewis diagrams. Have you done any of these work?
Not this year, but
Okay.
I have done it before.
I have done it before. Okay, awesome. Let me just grab a periodic table. It's always good if you have a periodic table open in front of you.
Um,
Whenever we
I
do
have
chemistry, we're always going to use a periodic table. Now, the most important thing here for chemical bonding is first to be able to see on the periodic table where's our metals and where's our non-metals. So I'm just going to make a little steps section there, like that. Now, some of these elements can be metals and non-metals. So we're not going to focus on that. I'm just going to focus on everything to the right of these pink steps. Now, everything to the right are non-metals. And everything else, as far as we're going to work now, is going to be metals. Okay. Did you know that, everyone?
Yes, sir.
James?
Slightly.
Okay, so everything to the right of that staircase, is a non-metal. Everything to the left are either alkaline or earth metals, or they are transition metals or whatever. Or some of them can be, depending on the conditions, be a metal or a non-metal. But we're not going to worry about that. We are just going to worry about the elements that are always non-metals. Now, the first thing you need to do if you want to draw Lewis diagrams, you need to find out if you're working with a bond between a metal and a non-metal, or if you're working with a bond between 2 non-metals. In other words, if you have your periodic table here, and I want you to draw a Lewis diagram of the bond between carbon and oxygen. That's called carbon dioxide. The first thing you need to tell me is carbon, is it a metal or a non-metal? In oxygen, is oxygen a metal or a non-metal? Quickly look on that periodic table and tell me if this is a bond between a metal and a non-metal or 2 non-metals.
2 non-metals.
Non-metals. Is that correct, Loving?
Yes, sir.
Very good. Then you're gonna draw Lewis dot diagrams. In other words, I'm gonna go to carbon and oxygen. There's 2 of them. There's an oxygen, there's an oxygen. And then I'm gonna fill in the valence electrons. Now, carbon is in group number 4. So carbon is going to have 4 valence electrons. Now, one of the electrons must be part of bond, like that. And then the two other electrons are going to draw separately. And then oxygen is a group 6. So I'm going to share electron for bonding. And then I'm not drawing the diagram correct now. I'm just showing you what we're going to do. Okay. So we're going to learn how to do this in a second. But I'm going to draw the Lewis diagram is going to be a Lewis dot notation. In other words, the atoms are going to bond by sharing electrons. Okay. So the diagram is going to look something like this. Now, this is not correct. So don't take this. Don't even draw it. Okay. So I just want to start so that you start right. Know how to start correctly. So this is going to be a Lewis dot notation. Why? Sorry, don't talk with me, please.
Check in. But yeah, there's an answer for you, but I don't know if they're going to mark the others.
So I've muted you, loving. Okay. Okay. This is because it's a non-metal bonding to a non-metal. Now let's say I wanted to draw a Lewis diagram between a metal like sodium and chlorine, which is sodium chloride. Then you realize, look, I've got a metal here and I have a non-metal here. Then we're not going to draw a Lewis dot diagram, but you're going to do 3 steps. 3-step method. Why? What type of bonding is this? Okay, loving, you can unmute yourself. It's quiet again. Have you guys heard the terms covalent bonds and ionic bonds?
Yeah.
Loving?
Yes, sir.
Okay. So for all covalent bonds, a covalent bond is a bond between a non-metal and a non-metal where electrons are shared. We're going to draw Lewis dot structures. And for all ionic bonding,
Yeah, it's not that. It's just.
for all ionic bonding, we're going to do 3-step method. And I'm going to show you today what this entails. It's not difficult. Okay. So we're going to start with covalent bonds. Okay. Right. Happy? Got your notes
Yeah.
here. I'm also recording this. I'll throw it on YouTube if you want it.
Yes, please.
Okay. Just always remind me. And the other thing is, loving, you can also record this if you want to. And James, you can also record this. Do you know how?
Yeah. Yeah.
Yeah.
Yeah.
Okay, so maybe I'm just going to test you. I want you to draw a Lewis diagram of hydrogen chloride. Do you actually know how to do this,
Yes, sir.
James?
I think so.
Okay, try it quickly. Both of you.
Yes.
So Lewis, and I'm also going to show you a Cooper diagram. Lewis and Cooper diagrams. Okay, 30 seconds. Draw hydrogen chloride. Is not a difficult one. It's an easy peasy one. Right? Put up your hand. There's a little hand signal or a yellow hand you can put up once you've completed the. Do you know how to do that, loving?
Yes, sir. Yeah, they can do.
Okay. Finished?
Yes, sir.
Yeah.
Okay, so hydrogen is in group 1. So hydrogen's got 1 valence electron. Chlorine is in group 7. So chlorine will have 7 valence electrons, but each one of them needs to donate an electron to bond. So there's one of the 7 of chlorine is already gone. So the other 6, I'm going to draw around the chlorine atom because that's the other 6 valence electrons. Now, very important. All the elements always want 8 electrons around them. They always want to be surrounded by 8 electrons. Do anyone know why? Because of all of those energy fields except the first one. The first energy field only consists of a 1s orbital, which can only take 2 electrons. But all the energy fields after that consist of s orbitals and p orbitals. Do you agree? And this is 2s and 2p, for instance. And 1, 2, 3, 4, 5, 6, 7, 8. So all of those shells after the first N1 can take 8 electrons. And that will give the bond stability. So now chlorine is really stable because chlorine is surrounded by 8 electrons. So in that energy field, it's got 8 electrons. And hydrogen only has one energy area for energy around it. So one orbital around it. So hydrogen is also very happy with just 2. Okay, so every element wants 8 electrons around it, except there's a couple exceptions. Hydrogen is an exception. Very important. Boron is an exception. And then also sulfur and phosphor are exceptions. Very, very important. Okay, so I'm going to highlight these and show you the exceptions. I'm only showing the exceptions that you need to know. So all of these atoms wants 8 electrons, or the energy level needs 8 electrons, but hydrogen can only take 2 electrons, while boron can only take 6 electrons around it. And phosphor and sulfur can take 8 electrons or 10 electrons around them. Very important. Those are exceptions. You need to make a note of that. So now we've drawn a Lewis diagram of the bond between hydrogen and chlorine. Okay. What would a Cooper diagram look like? It just will be hydrogen / Cl. That's a Cooper diagram. Instead of the bond between the two atoms, I make a small line and I don't put any valence electrons on atoms on the side. Happy?
Yeah.
Very easy, very easy. Very good. Okay. So the next one, that's really important. I'm only going to run through a couple of them to show you how to do it. Let's do oxygen gas. Tell me, metal, non-metal, or 2 non-metals?
Two non-metals.
2 non-metals. So there's the one oxygen. Okay, that looks like a circle. There's the one oxygen. There's the other oxygen. They both have 6 valence electrons because they are in group number 6. So they need to share a pair. Look at that. One oxygen each gave 1 electron to share because electrons are shared in covalent bonds. So each one of those has only got 5 electrons left. You see that?
Yeah.
And the other oxygen only also has 5 electrons left. But now look at this. The problem. This oxygen is not surrounded by 8 electrons, but only how many? 2, 4, 6, 7. You see that?
Yeah.
And this oxygen is also only surrounded by 7 electrons. So that means you have to take one of the lone electrons here, unpaired ones, and you move it in there.
So you move it to the side so it's like conjoined or something. Yeah.
Pardon?
Do you move it in the middle so it's like conjoined, like
Yeah.
you
You
can tell
move
it's
them
shared?
towards the middle where they bind, towards the bond. See that?
Yes.
Okay. So now look at what happens now. This oxygen on the left is surrounded by 2, 4, 6, 8 electrons. And the one on the right is also surrounded by 2, 4, 6, 8 electrons. So both of them are happy. It's called the octet rule. Octet rule. What does a octet mean in music? It's like not a group of 8 chords or something.
Yeah.
So 8 is octopus, 8 legs, octet rule. So this is my Lewis diagram. And my Cooper diagram will look like this. There's a double bond between the two oxygens. And I'm not putting in the valence electrons that's not bonded. You'll see Cooper diagrams are much easier to draw, actually. Okay.
Yes, sir.
Okay, now the good news actually is these diagrams are so easy in grade 10. There's about 8 of them in your book, and you'll always get those. You won't get other ones. So, I mean, if you these are basically the ones you're going to get. You're going to get either 2 group 7 metals, like say for instance bromine gas. You're going to get ammonia, your oxygen gas, which we've just done, carbon dioxide, water, which is a really important one, and nitrogen gas, and something like hydrogen chloride, which is group 1 and a group 7. And this is 2 group 7 atoms. These are the ones you're going to get, some of them. Okay. So you can this, there may be 1 or 2 in your textbook, but if you study them, you'll always get them. So
Yeah.
look at this, NH3, there's nitrogen surrounded by 3 hydrogen atoms. Now, each hydrogen atom only has 1 valence electron, so I'm going to put it in there. And the nitrogen is in group 7, so that's going to be 1, 2, 3 of its valence electrons. Oh, sorry, nitrogen is group 5, so it's only got 5 electrons. So I'm putting a 3 in there, and then there's 2 remaining. And there's your diagram. Look, all the hydrogens are surrounded by 2 electrons, and they're happy because their shell is full. They can only fill the 1s orbital, while the nitrogen is surrounded by 8 electrons. So that's done. And the Cooper diagram will look like this. I put a line there where the bond is, and then there's 2 valence electrons there. So you always add, in a Cooper diagram, you only add the valence electrons on the center atom, not on the side atoms. Okay, what I want you to do is, okay, so we're going to do water first because that's probably the most important one. H2O. Now, look at this. There's an oxygen. This one you're going to learn. You're not going to, you are just going to learn this one. It looks like this. There's an oxygen, and then the one hydrogen is there, and the other hydrogen is there. They're not allowed to look like this. That is totally wrong. This is wrong. Your textbook might do this just because it doesn't know how to print it any other way. That's also, in a sense, wrong, but it's accepted. So now I have a bond here between the hydrogen and the oxygen. And the hydrogen's got only 1 valence electron, so it's given. Oxygen's got 6, which is gave 2 away already, so it's got 4 left. So the other 2 is on the one side of the oxygen, not at the bottom. So you're also allowed to draw it like this because the textbook does it. The problem is the angle is not 90 degrees. The angle is 104, something, 104.9 degrees, not 90 degrees. This one gives you a 90-degree angle, which is actually wrong. So the Cooper diagram looks like this. Oxygen, hydrogen, hydrogen, 2 pairs of unbonded electrons. So this is Lewis. Sorry, my pen is struggling today. Lewis, and this is Cooper. And And this you have to learn. Okay. So my take is, look, the Lewis diagrams for covalent bonds are so scarce in grade 10 in the fact you only get like, I only have 6 here. I think I've numbered it wrong. It should be 7, but I think your book's got like 8 or 9. You are only going to get some of those in the book. You're not going to get creative and ask some out of the textbook. So just learn those in the textbook. Why? Because figuring out the Lewis diagram takes time. If you know what it looks like off by heart, you can just draw it and save a lot of time going on to the next question. Do you understand that, Loving?
Yeah.
And James? At the moment, I've muted you, Loving, because there was someone talking at the background. Okay, good. Right. So go to your textbook and then learn it. I mean, the carbon dioxide one is very important. This one, the nitrogen gas is important, the water is important, and this one, all of these are really important. This is so easy, and this one is easy. The bromine will look like this. There's one bromine there, there's one bromine there. They share a pair, and then each one of them's got 6 left. So it's automatically done. There we go. That's basically what the Lewis diagram. Just one thing, it's not wrong to make everything dots. Okay, I don't know, but just do exactly what your textbook does. But it's not wrong to make everything dots. The textbook will probably just make dots and crosses to distinguish between the electrons. Okay.
Okay.
Right, now we're going to move on to ionic bonding. Very important. Ionic bonding, electrons aren't shared. Electrons are transferred, not shared. Why? Because we have a metal bonding to a non-metal. Now, the non-metal is much stronger. Much stronger. It's called, it's given an electronegativity value. Now, the value, I'm going to show you on the periodic table. I'm just going to clean this up. Look at this value that we haven't used yet. So I'm going to give you the sodium. Look at this value there. It's 0.9. You see that value there? That's the electronegativity of the element. That's an indication of how well or strong that atom can draw electrons towards it. So that's 0.9. That's a metal. Look at all the metals there. 1.0, 0.8, 1.2, 1.5. Calcium is 1.0, etc., etc. Can you see those low values? Then look at your non-metals on this side. Look at chlorine. It's got 3.0. Fluorine, 4. Oxygen, 3.5, 2.5, 3.0. Look at those high values of electronegativity. So that means what? Non-metals can actually attract electrons towards them much stronger. So the electron will jump, not be shared, will jump towards the non-metal. It's like taking candy from a baby. When there's 2 babies sharing candy, then and each one of them are equally strong, then they're going to share the candy equally. But if there's like an adult person, you can just take the candy off the baby. It's exactly what happens here. The non-metal is so much stronger. It doesn't share electrons. It just takes the electron away from the metal. And then ionic bonding takes place. Its electron is transferred from the metal to the non-metal. So from the metal to the non-metal, electrons are transferred. And we're going to do this in 3 steps. So let's do the first one. Sodium chloride. Now, sodium is in group 1 on your periodic table, and this is in group 7. So this is a metal and a non-metal. So step 1. I don't know if you've seen this. We're going to take the metal, sodium. It's in group 1, so it's got 1 valence electron. And then that metal is going to lose the electron. It's going to become sodium plus 1. And then losing the electron looks like that. It gives away electron. Then step 2 is the non-metal grabbing the electron. So there's chlorine. Chlorine's got 7 valence electrons. Look at that. And it's adding 1 electron to it. And then it becomes chlorine ion. Okay, Loving, have you seen this? Shamal. Okay. Shamal, just pick up. Have you seen this?
Yes, sir.
You have
Yes,
seen
sir.
this. Okay, awesome.
Yes.
So this is called an ion, and it's got a charge of -1. So I'm putting that charge there. And then step 3 is where the ion of the metal bonds with the ion of the non-metal. You can make all of these dots. They don't have to be crosses and dots. And that becomes sodium chloride. Now, I think, James, you've also seen this.
Yeah.
Okay, good. Good, good, good. Very important work. Write that down. I'm going to do another one, or you're going to do it, try another one. I'm just going to make it slightly more difficult because you've seen this. So they're going to ask you in the exam. Can we continue, Loving?
Yes, sir.
They're going to ask you, they're going to be try and catch you out. They're going to do the following. They're going to ask you, draw a Lewis diagram of magnesium bromide. Okay. Then you must realize, you must first be able to write magnesium bromide just off the paper. So magnesium looks like that, and bromine looks like that. Okay, can someone help me? What is the charge of the magnesium ion? If you go to your periodic table, you'll see in what group it is, and that will give you an indication of what charge it will have. Who can tell me? What's the group number? 2. So magnesium is a metal, it become 2 plus. And bromine, where's bromine? Bromine.
It's -1.
It's in group 7, so it'll be -1. So if I draw this together, look at this. So cheat. Remember this cheat. That value goes there, and that value goes there. So it's magnesium bromide. So that's your answer. But because it's a metal and a non-metal, we're going to do it in 3 steps. And I want you to try these 3 steps on your own quickly. The diagrams sometimes can catch people out. They think they have to draw a dot notation, but this is because it's a ionic bond, it's 3 steps. Just remember to tell me when you're finished. Step one is what? The metal.
Yeah.
Yes.
I think I'm done.
Miss Mbula, how are you doing?
And that's it.
It's very helpful if you put your video on, Loving, because then I actually can see when you're finished or not. Huh?
Okay.
Thank you.
That's it.
There we go. Then I can see if you're looking down or looking up. Okay, magnesium's got 2 valence electrons. Why? Group 2. So it becomes magnesium 2 plus by losing 2 electrons. Well, bromine is in group 7. Okay, so it only has space for 1 valence electron. Can you see that? If you only grab 1 electron, and look at this now, very important. So it becomes Br, and I'm gonna fill those. You can do crosses and dots or whatever. That becomes Br1 minus, but a big problem. I need 2 of those. Can you see I need 2 bromines? So I'm gonna multiply the bottom equation with 2, just in brackets. You have to write that. Okay. So in a sense, I've got 1 magnesium, 2 plus ion. That's going to be bonding to 2 of those bromine ions. Just filling these. They want these little dots there to show you where the electrons are. And then that becomes MgBr2.
Okay.
Okay. Happy?
Yeah.
Okay. So just a question, in your work, in the work that you've done this year so far, Loving, you haven't done waves at school yet or in your breakdown. Could you hear me, Loving?
Oh, yeah. So I did it out of school.
You
Like
did?
I've done it before.
You done it this term?
Yeah, but not in school.
Okay. Where did you do it?
Was it last year during grade 9? Like at the end of the year, we just touched on it.
Oh, in grade 9. Okay. Right. We do one more. Okay. I want you to do a Lewis diagram of calcium oxide. Okay. On the periodic table, please find calcium for me. What group is that? A calcium oxide is probably 2 words in English. Yeah.
It's in group 7.
No. No.
No? Oh, group 2.
I'm just going to copy this quickly. Calcium, it's in group 2. And oxygen's ion is oxide.
Yeah.
Loving, focus. Okay, help me out. Help me out. Right, so calcium, step 1. Calcium is a metal. And do that. And then 2 is the non-metal, and 3 is where you add it together. See if you can do that.
Which one? Anyone? Want to memorize them? I'm not gonna do the same.
Okay, I'm done.
Okay. Remember to put up your hand once you've done. Loving. Okay.
Done.
Calcium is in group 2, so there's 2 valence electrons. So it's got 2 electrons to give away. It will become 2+ when it gives out 2 electrons. Oxygen is in group 6, so it's got 6 valence electrons. It will grab 2 electrons and become oxide. Oxide is just the term for the ion of oxygen. Okay, and very nice. Both of them has got 2 electrons, so we don't have to do any modifications. So the calcium 2+ ion will be added to the oxygen ion, which is called oxide. You can little do dots there, you don't have to do crosses, and that will give you CaO. But you knew that calcium was 2+ and oxygen is 2-, so that's just easy peasy. They bond really nice to calcium oxide. Okay. I want you to finish off those tests on the atom and generate questions out of that. The next tests are going to be on Lewis diagrams, and I'm only going to dish out those tests next week. Then also important, you should have an assignment for the term.
Yeah.
Okay. Just forward that to me. We need to run over it some other time. Okay. Okay. Remember, there's only a month left. There's like 4 lessons left. Then we finish the term's work. Okay.
Yeah.
What else do we still need to do this term? Do you know?
No.
Okay, maybe one of you can also send me a breakdown of the term's work. I just want to make sure maybe I've got that already. Yeah, here we go. So this is the work that's required. Phases of matter and the molecular kinetic model. That's like heating and cooling curves with a kinetic model. And then what we've done is the atom, the periodic table, and we're busy with chemical bonding at the moment. And then in the physics, we've completed transversal pulse waves, longitudinal and electromagnetic. So we are busy with chemical bonding. We only have this little section left. And I think I'm really pretty sure that your assignment should also be on phases of matter. So it's going to be on, you're going to take water and heat it up until the ice melts type of thing and make a graph of that. Okay. So we're doing really well. Okay.
Yeah.
Yeah. We're doing really well. So we are busy with chemical bonding. There's some work to do still on chemical bonding. Okay. There's like 2 lessons left. And then the phase of matter, I want you to start with your assignment on that as soon as possible so we can generate questions out of that. Okay.
Okay.
Good. Keep well. See you next week.
Bye-bye.
Bye-bye.
Bye.